In English ya ini ya.
Pak Emon in Indonesia.
Masuk iki wis.
Oke. Assalamualaikum warahmatullahi wabarakatuh. A very good afternoon to all of you who joined this international guest lecture this afternoon. I would like to welcome you all to our international guest lecture in the research method, especially with the Associate Professor Yogi Prasetyo, entitled Applied Structural Equation Modeling for Academic Research, Bridging Objective and Subjective Measures. So in this beautiful afternoon, we are very delighted to have Prof. Yogi here. Hello, Prof. Yogi.
Hello, good afternoon.
Thank you for coming with us.
You're welcome.
It's our pleasure to have you.
It's a pleasure.
Thank you. So, ladies and gentlemen, and also students, in this afternoon, we would like to have the international guest lecture. And in this session, will be led by Dr. Satria Fadil Persada. So please allow me to move the virtual microphone to Dr. Satria Fadil Persada to lead these sessions. Dr. Satria?
Okay, thank you, Ms. Dewi.
Thank you.
Yes, okay, thank you. Before we start the guest lecture, I would like to show you all about Dr. Yogi, brief introduction, brief profile about his career. So, Dr. Yogi actually is an Indonesian, but currently he working at Mapua University on Philippines. He was graduated from the University of Indonesia with the title of Bachelor Engineering. He also doing the exchange program to Waseda University at Japan with the specific course, specific field of Industrial and Management Engineering. And then he continues to pursue the master degree at National Taiwan University of Science and Technology with the major of Industrial Management. He got his MBA at 2015, and also he continued his doctoral degree in the same university and graduated at 2019. So, and also Dr. Yogi has a lot of publication. The publication mostly on the reputable journals such as Elsevier Publisher, IEEE, and many more. Dr. Yogi, the research, the focus research that Dr. Yogi conduct is related to applied structural equation modeling, the use of meta-heuristic, the mathematical modeling, usability analysis, and accidental analysis and prevention. He also has the 15 published proceeding in the conference, and many more of manuscript and publication will be conducted because basically he likes to write a manuscript and like to publish a paper. And also Dr. Yogi has a good index for the Scopus and Google Scholar. This is considered as the high impact for every researcher level. And then in this moment, in this session, he will share about his knowledge regarding the use of the structural equation modeling, bridging the subjective and objective. Okay, without to delay, I would like to welcome Dr. Yogi to present his discussion, his materials to us to give us many insight for conducting the structural equation modeling research. Dr. Yogi, the time is yours.
Okay, so thank you so much, Dr. Satya. Anyway, Dr. Satya is actually, my friend since 7 years ago, I think, isn't it? Yeah, I think 7 years ago, right? Yeah.
Yes.
Yeah, 7 years ago. So it's actually a pleasure, to be invited by him in this afternoon to share my knowledge about structural equation modeling. Anyway, Dr. Satya is very expert in structural equation modeling too. Perhaps he's actually more advanced than me. Okay, so in case that there is a difficult question, then they can discuss, how to answer that question. But basically, that I would like to go a little bit different direction with Dr. Satya's publication about SEM. So in here, actually, I would like to focus more on bridging objective and subjective measures. Okay, so the title is very clear: Applied Structural Equation Modeling for Academic Research. Okay. Bridging objective and subjective measures. And I'm Dr. Yogi. I'm from School of Industrial Engineering and Engineering Management in Mapua University in the Philippines, Manila. So, this is actually my short introduction. Actually, Dr. Satya already mentioned this before, but basically my specialty is actually human factors and ergonomics. Okay, so anyway, this is the agenda of my presentation for this afternoon. Okay, I know all of you might be very, perhaps some of you are already very expert, some of you are just a beginner. So I would like all of you to start with the lowest level or the easiest level, then we go to the most advanced level. Okay. So before we know structural equation modeling, you have to know the basic first about the basic statistics, about the correlation analysis, then we go to linear regression, we go to factor analysis, then we go to the final one. That's actually what we call structural equation modeling. So I would like to bridge all of you from the very beginning, from the very basic, and then we go to the very advanced, okay? Okay, so let's go back to the very basic statistics, very, very simple basic statistics, okay? And this table is actually like, holy table for all of us, because in case you forget what kind of statistical analysis that you do, is actually you just check this table again, okay? I believe all of you already know what is nominal, ordinal, and then scale. And scale in here is actually interval and ratio, okay? So nominal is like a male, female, ordinal is like Likert scale 1 to 5, and then the other one is actually the scale or the ratio, okay? And so first of all, you have to check this one first, the measurement scale, and then you have to check how many samples happen, like that you collect in your research, okay? So let me start with a very simple question, very basic one, okay? Okay, this is example of sales data. Okay, so sales year 1 and sales year 2 from several different companies. Okay, my question is very simple. Is there a significant difference between year 1 and year 2? So let me ask, okay, what kind of statistical analysis you should use? Can someone try to answer?
Structural equation model.
Can someone answer? What's the statistical analysis? Okay, let me guide it to you. Okay, this is a sales data. So is it nominal, ordinal, or scale? Which one? Can someone answer?
Nominal.
This is what? Yeah, this is the scale. This is the scale data, okay? So if you check in the table, okay, the previous table, okay? In the previous table, so it's going to be what? Scale, right? So everything is going to be here. The answer is going to be in here, okay? Next, how many examples of the data? How many examples in here? There are only 2, right? If there are only 2, so if you go back to the table, then it's going to be here, 2 sample tests. Okay, then we go either is it related sample or independent samples. Is it between design or within design? Okay, so this is the same, right? They just used it from the same person, the same company. So that should be what? That should be related samples, right? That should be related sample. You just compare within design. Then what's the answer? It's going to be pairs. I mean, t-tests or pair samples, okay, or pair sample t-tests. Okay, so that's actually the way we start, from the very basic. Okay, so Dr. Satria said structural equation modeling. Wow. So we use how you say that a simple, I mean, the right tool for the right problem. Okay, let's go for the next one. So this is one of my SCI publications. Okay, this is actually also utilize structural equation modeling. You can download it in Science Direct. But this is actually very human factors and ergonomics. That's very my field. Okay, but let me explain it in a simple way. Okay, what I did in the experiment is actually like this. I asked the participants to click the ball. This one, the ball, the virtual ball. Okay, as fast as possible. It's like from here to here, here to here. Something like that. And then I collected the time, and also I collected the location in here, so I can do several algorithms to extract the data, to get the position and also the time. Okay, so in here, okay, they they have to. This is actually example of the easy one, and this is the medium one. This is the hard one. Okay, and I have 6 in here. Basically, that's the story. Okay, so one participant completed 6 different levels of IT. This is actually index of difficulty, okay? And there are 12 participants. I want to know the effect of this one, okay? The effect of this one to the reaction time or to the accuracy. Okay, and my question is simple, what kind of statistical analysis you use? Okay, so, I have to push all of you to understand the very basic statistic before I go to the advanced one, okay? Because this is going to be a very important foundation for all of you, okay? So first of all, you use the same subject or different subject? That's the first question. That's the easiest how to start, okay? Since you use one participant completed 6 different levels of ID, then that's within design or between design. Is it different sample or the same sample? It's the same sample, right? It's within design, right? It's between design. And I have so many, how many? It's like 6 in here. So if you answer that question based on the table that I show in here, okay, I got everything in scale, and the sample is more than more than 2 K samples, and then here related samples, okay? Related samples. So in here, I use repeated measure ANOVA. Okay, it's different with ANOVA. Perhaps all of you just say, oh, just use ANOVA. I mean, like, it's a bit different, because in here we use repeated. I mean, exactly the same sample. One sample, you push them to do 6 different, 6 different level of IDs. So that's why that the answer is actually you have to do the repeated measure ANOVA, not one way ANOVA. Okay. And then, the next one. This is actually the same publication, okay? This is actually my publication also. So I asked the participant to do the task in 2 different levels of environment in here, okay? So we have environment 1 is actually 3D TV, and then environment 2 is actually the 2D TV, okay, in here. And again, one participant completed 2 different levels of environment, and there are 12 participants. So there are so many samples in here, so K samples. And then here I also use the what about that within design. So here the answer, what kind of statistical analysis that I that the correct one is the same: repeated measure ANOVA. Okay, so if you have something like one participant and then they have to finish several different levels, it's different with the questionnaire base. If questionnaire, they only do they only have to answer the question once. But if the object, you have to do like several different things, several different levels, then you have to run what we call repeated measure ANOVA. Okay, that's very common in the ergonomics, but I don't know about the other field. Okay, and this is also my another publication. You can check in the, you can download it also. Okay, here, different question. Okay, because my another specialty is actually about the camouflage and the military camouflage. And then here, I have a design 1, 2, 3, 4, 5, 6, 7, 8, and so on. I tested the design in different locations, but the problem in here is I only care about the average. So one design, it has one average value only. So what statistical analysis I do for this one? This is also the same. This is a scale one. So let me check. Is there someone who answered it correctly in the chat or what? Okay. Can I ask Dr. Wira? Dr. Wira is here. So it's very simple actually, the answer. It's just what? Because one and one, how is that? One design and one average, and you don't need to do it repeatedly. So basically, the answer is just ANOVA. You just should do simple one-way ANOVA. For this kind of study. Okay. So a little bit different between one-way ANOVA and then repeated measure ANOVA. Okay. Okay, so basically that's the basic statistical analysis that you need to acquire, before you go to the next level. Okay. Okay. So we already finished the t-test. Okay. We finished the t-test already, and then we finished the ANOVA, and then repeated measure ANOVA. Okay. I think that's going to be very useful for engineering, engineering or medical related. Okay. Okay. Let's go to the next one. It's actually correlation analysis, okay? So correlation analysis is actually the foundation for structural equation modeling, okay? As long as you have a correlation, there is a correlation data, you can do anything about it. You can do linear regression, you can do structural equation modeling, you can do factor analysis. It depends on what is your goal. Okay, so if you have multivariable, more than one variable, okay, and then the data is actually hundreds or thousands or thousands data, you can do simple correlation analysis. If you don't know the nature of the data, I mean, is there a strength or like relationship between these two or more variables? Okay, so if you have something like this is actually the same. Like my publication with our best friend, Dr. Noah. Is she here? I don't know whether she's here or not. But anyway, look at this one. 1, 2, 3, 4, 5, 6, 7. And then here is actually 1, 2, 3, 4, 5, 6, 7. Okay. So if you have a correlation table like this, for example, one variable correlated with with other variables. So starting from here, you can do structural equation modeling. It depends on how you gonna create the story. Okay, I know most of the students in here are from business, but perhaps some of you are like me from human factors. We got the metric data, we got the scale data like this. We got we extract the data from algorithm, and then we try to see the relationship between those variables. Okay, so as long as you have this one, you can start structural equation modeling. And then if you do the how you say that, if you do the correlation, leave it blank, the other triangle blank, so it will look tidy and it will look beautiful. Okay. So up to here, so far so good. So far so good up to correlation. For paired t-test, Anova, repeated measure Anova is, very basic, but we start SEM from the correlation. Okay, so far so good. Can I ask the moderator? You okay? You feel okay? Dewie? So far
Yes.
so good.
So far so good.
Okay, so far so good. Okay. Okay. So let's move on to the next one. Okay. The concept of structural equation modeling. Okay. So we go to the next one. It's actually regression. Here. Okay. The story of structural equation modeling is like this. Okay. Let's go back again to your basic knowledge about the regression. Okay. Regression is actually y equals to b0 plus b1 and then x1. Okay. And y is actually your dependent variable, and then x1 is actually your independent variable. Okay. And the difference between the linear regression and multiple linear regression is just very simple. For a multiple linear regression, you have more than one. Okay. More than one independent variables. But anyway, can I ask all of you, do you know what is B0? Can someone answer me what is B0? I want to test your knowledge. How far you know about this one first? Your voice is unstable. Oops, sorry. Let me try to adjust. But what is B0? Can someone answer what is B0? What is B0? B0, can nobody can answer that one. Constanta. Not exact. What constanta? What constanta that one? What constanta is here? I would like to know the exact answer. Not just the constanta, not just the constanta. If in this picture, what is B0? Do you understand that one? Yes, very good. Oh yeah, I know this guy. Long time to see. Yeah, of course. Okay, he's so good at math. This is actually the intercept. Okay, B0. From here to here is actually what we call the B0. Okay. So can I ask, can B0 be negative? Can the value be negative? Yes, of course, it can be negative too. For example, this one, this line, you project this line up to here, then it will be perpendicular in this area. So the B0 is going to be negative. Okay. Okay, so that's going to be okay. And then here, B1 is actually just the constant, the constant or the beta value. Okay, and then x1 is just the variable. Okay, and then here we talk about the limitation of the multiple linear regression. Okay, this is the first story why there is a structural equation modeling. Okay, here the story is very simple. Okay, multiple linear regression, it cannot predict 2y at the same time. You have to run it separately, like y1 and then you run it, and then y2 and then you run it. You cannot predict this one. If you have more than one y, for example, y2, y3, y4, and so on, you cannot you cannot do that simultaneously. You have to do it one by one. Okay, that's the first limitation of multiple linear regression. The second limitation is you don't know that the causal relationship among this variable, among the independent variable. For example, x1 and x2, yeah, perhaps they actually x1 influence x2 and they go together to this y. Okay, so multiple linear regression cannot answer that this question. Okay, so that's why we need a certain, I would say, more advanced technique more than multiple linear regression. Okay, if you only have a very simple, you just want to develop mathematical model, and then you just use multiple linear regression, it's fine, But if you want to see the causal relationship among so many variables, then you have a trouble in here. You cannot use multiple linear regression. So that's why you need a more advanced method, okay? This one I'm not gonna explain it in details because this is not the main goal of this meeting, but all of you, need to pass this assumption for if you want to run a multiple linear regression, okay? Okay, so there is another one. Okay, this is from the same data. Okay, it's actually from the same data. Like I told you before, as long as there is a correlation, you can do so many publications. This is my another publication. I just use some multiple stepwise multiple linear regression, to predict accuracy. It's actually like that. So as long as you have the data, keep it there. You can squeeze the data and do several publication, and then the story is different. The story is different and unique. Either you want to create mathematical model, or either you want to explain the causal relationship, or just you want to test the effect only. Okay, so and then I would like to persuade all of you that if you have low R square, don't be, I would say like what? Don't be afraid, because low R square, you can always, how is it that, as long as you can find a significant, in here, significant indicators in here, you can expand your publication. Okay, so don't be shy if you have a low R square, especially when the topic is actually very rare. So you can just publish it. Okay, so all of you understand about the correlation already. You already understand about the limitation of multiple linear regression. The first story, why there is a structural equation only. So that's the first story, okay? Then we move on to the next level, what we call exploratory factor analysis, or we call it just factor analysis, okay? But the complete name is exploratory factor analysis. So exploratory factor analysis is like this, okay? Just imagine, okay? All of you are there, and you like certain colors. For example, like me, I like purple. So I don't know, Prasetyo, what color you like? Green, blue, So some of you like green, some of you like blue, some of you like purple. So you go to the one box, and we try to rotate the box. And after we rotate the box, then the one who love purple will go to one group, the one who love blue will be in one group, and the one who love green will be in one group. Okay, so after so many variables like that, you don't know which one you can group. You can group each other. So you can just apply exploratory factor analysis. Okay, so this is it's gonna be like this. Some of you will be in one group, some of you will be in another group. Okay, but the difficulty for the exploratory factor analysis is like this is an example of the exploratory factor analysis. You have to give the name. What's the name? For example, this one. Some factors in here, they go to the same group. The same, for example, group 1, group 2, group 3, and then so on. Okay, so how are you gonna name this one? What that can cover all of these factors. So that's actually the challenge for the exploratory factor analysis. Okay, so for example, you have so many groups like that, and so many factors like here. You just want to reduce that. You want to reduce the factor. So that's why they call it factor analysis or exploratory factor analysis. Okay. So basically, the difficulty is actually the grouping. The naming, not just the grouping. Actually, the naming. Okay. Okay. Then after how many minutes? 20 minutes. Then I enter the main topic. For this afternoon is actually the structural equation modeling. Because if I just explain what is SEM, all of you will not understand what is that. I mean, I know some of you already know, already very advanced. But the students in here in the research method class, perhaps like it's your first time hearing the SEM. So the story is like that. You have to pass all of these, then we go to the main point. It's like structural equation modeling, or the other name you just call it confirmatory factor analysis or path analysis. Okay. So let's see. Okay. I would like to introduce first the basic knowledge about the SEM. Okay. So SEM is actually a combination of factor analysis and regression. So I got it. This is a combination of those, okay? Because the limitation of the factor analysis, the limitation of the regression, and then we combine it with the factor analysis, then we name it structural equation modeling. And this method is actually booming with the 30 years ago, perhaps, when the computer is really well developed, because doing structural equation modeling is actually depends on the computer during that time, during the early age of the SEM. Okay, so and this is actually my own statement. Okay, this one. Usually, if you have 250 data, it's good enough for if you would like to run SEM for subjective natures. For example, questionnaire. Okay. 250 data, so it means you have to have 250 respondents. Okay, but for objective measure, let me show it to you my findings. Usually you get the 150 data. It's already very good. I usually find a good model when you only have 150 data. I'm not talking about participants, okay? Because one participant can have, for example, 12 data. Okay, 12 data. Then 150 data, you can get from only 12 participants. Because I have some, I would say, disagreements with some researchers, because some researchers stated that at least to do SEM is 250 respondents. But hey, don't forget, I'm from human factors. Perhaps I'm from a different field point or different point of view with you. And then it's actually the data, not the number of the respondents. I will show you what is the data in here means. Okay. So I will talk about the terminology of that. Is the terminology of structural equation modeling. Okay. So here is actually the story of the multiple linear regression. Okay, just imagine you only have one Y, right? In multiple linear regression, right? And then you have, let's say you have two, okay? X1 and then X2, okay? But the difference in here, what's the difference between here and multiple linear regression? The difference is here, you can see that there is a relationship between the independent variables. Okay, so this is like the same, exactly this, almost the same with the multiple linear regression. Okay. Let's go to the more advanced one. This is the story. When if you have two Y, I would say that two dependent variables, and then do you have to do it? You can do it twice. Multiple linear regression, like this one and then another one. You can do it like that. Okay. You can do it like that. But it takes time to do it like that. So with SEM, you can do it simultaneously, okay, at the same time, together, and you can see the causal relationship also. Okay, up to here, so far so good. So far so good. I would like to check first. Dewie, so far so good.
Hello, Pak Yogi. Unfortunately, the voice is still unstable a little bit.
The voice.
Or could you try to turn off the camera? We can try whether the voice is clear enough or not.
Okay, let me try that one. Okay, let me stop the video. Is that okay? Is it better or not?
Yeah, I think it's better.
Really, much better?
Yeah, much better rather than maybe the connection, just share the
Yes,
bandwidth
perhaps. Okay.
video and then
Okay.
quiet.
And then for okay, then I just turn it off. Okay. And then so far up to here about the concept. Do you understand so far? You can follow the concept of the limitation of regression, and then we go to the structure equation modeling. So far so good. You can follow the story.
Yes.
Really? Okay. So you can follow the story, right? Okay. So okay, it's good. Okay. Okay, so let me continue that one, okay? Let me continue to the next one. Okay, here. For example, in here, in this model, what you can see is actually here. The same like a multiple linear regression, but you can see I would say that the causal relationship in here. And then you can also do it like this one. This influence this and this influence that. And so this is going to be a mediator, for example, A, B, C. A influence B, B influence C, A influence C, for example, like this. So you can do like mediating a story like this. For example, I like, how I say that? I like purple, for example. And purple, I like, for example, I like fish, and fish like what, something. And so you can have the relationship between me and the final variable in here. So you can see like the mediating, something like that. Okay. And this is actually another model. It's actually just like a factor analysis model. So how good you are representing in that in that group. For example, I like purple and she likes purple too. But you can see in here, later on, you can see in here how big my love to the purple, perhaps it's much bigger than the X2 in here. We are in the same group, but you can also see who loves the purple more, actually. Okay. Okay. So far so good up to here. Yes. Okay. Many people already say yes. Then let me explain what's the terminology of the structural equation modeling. Okay. Okay. This one, the how's that, square or oval one. This is what we call latent variable. Okay. And this is actually the square one. You call it indicators. Okay. What's the difference between latent and indicators? It's actually, indicators is like you can get that directly, you can get the measure directly. You can get the value directly. For example, like gender, for example, like age, for example, like here, like SAT score, high school score, whatever that is, And then latent variable in here is actually, you cannot get that, but you just put it in here as one big group. They call it academic performance, which measured by SAT score, high school GPA, and then ACT score. So in here is actually how good this one representing this one is actually this path. Okay, this path we call it factor loading. The factor loading should be from the latent to the indicator. Okay, that's what we call the factor loading. Okay, this is actually also the factor loading. Okay. And then usually the factor loading, the minimum cutoff usually actually 0.7, okay, 0.70. But when it close to 0.7, usually we still just include it. For example, like this one, it's still fine. Yeah, usually it's still fine. Okay? It's still significant. Okay, this is actually the factor loading. How good this indicator represents this academic performance. For example, like my previous story, how strong my love of purple to the, compare with the other, other persons in here. So for example, for me, these are 82. So this is actually the highest, a very good representation for this one. But the rest is still good, but this is actually the better one. Okay. And then here, the relationship between here, the latent and the latent, we call it beta coefficient. Okay, just like the beta coefficient in the multiple linear regression, exactly the same, the beta coefficient. Okay, so if you ask me like, oh, sir, what's the cutoff, you know, for this one, you know, there is no minimum cutoff. As long as it is significant, it is fine. So how can I see that? Oh, you check the p-value, you know, there is a p-value in here in the software. Okay, later on, there is a p-value in here. Okay. Okay. So, oh, this is Dr. Felix. Hi. Okay. Is it the coefficient correlation or the beta from linear regression? The same, Dr. Felix, exactly the same. You know, if you, for example, either you do it like this one, Dr. Felix, like intelligence to academic, or you just do it like this, double arrow like this one. If you do it, you just want to do correlation, it can be. But if you do it like A influence B, this is actually the beta coefficient. Either you do it like regression, up to you, or you just want to connect it like double arrow, covariance, like this one to this one. Just like, you know, this is like one arrow, like you can do it like double arrow. So double arrow like that. Let me show it to you later, Dr. Felix. But it's the same like the coefficient correlation or the beta from the linear regression. So Dr. Felix, do I answer your question in here? Okay, very good. So it looks like everybody can follow, okay? Okay, so this is what we call another one, the next terminology, okay? This is what we call exogenous latent. This is what we call endogenous latent, okay? This is the endogenous latent, okay? And there is an error in here, just like a regression, but we usually do not really care about this one, okay? So actually, there is a factor loading, there is a beta coefficient. Up to you. You want to do it like one way like this, or you want to do it like arrow, you know, like just a high degree of correlation. You can do it like that also in using the here, you know, in here. I'll show it. I will show it to you my publication last month. No, not last month. This month actually, 2 weeks ago. I will show it to you after this one. Okay, this is my recent publication with COVID-19. In the Philippines, okay, I integrate protection motivation theory and extended theory of planned behavior. So this is actually very social psychologist or the public health, you know, study. Okay. Okay. So perhaps you don't know, like, oh, sir, I don't know what is latent. I don't know what is indicator. Okay, very simple. Okay, very simple. Indicator is actually this one. You get the value, right? For example, I do understand the transmission of COVID-19 and then scale 1 to 5. I measure it by Likert scale, 1 to 5. I do understand blah, 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 you know, incubation period of COVID-19, 1 to 5, something like that. So do you have the value of this one? Yes, you have the value of this one. So what is this? This is what we call indicator, okay? But this one, you know, I would like to name it, I would like to create a group for U1, U2, U3, U4, U5, you know, I name it understanding of COVID-19. But do I have the value of this one in my Excel data? In my Excel data, understanding of COVID-19, 1 to 5. There's the data or not for this one? In the questionnaire, can I ask you first? Can I have this data?
No.
Yeah, no, right? I don't have this data. So that's why this is what we call latent or unobserved variable, okay? You know, unobserved variable here, okay? Unobserved variable. This is what we call observed variable. You get the data directly. This is you don't get the data directly. So this is what we call latent. This is what we call indicator in terms of the questionnaire-based study, okay? You can also get the metric data. Let me explain it to you later. Another, you know, example, okay? So here, for example, this one, family, adjust, achieve, cognitive, okay, something like that, you know. So here, family, there are two, either this is a questionnaire or this is either the metric data, or this is, you know, either questionnaire or this is a metric data, you know. You can just correlate like this simultaneously. Can you imagine if you do regression, like this one by one like that, and then you do regression again from here to here to here, like how many regressions you have to do? It's so complex, you know. I mean, if you do it by regression, you can just do it simultaneously by the structural equation modeling, you know, something like this. It's very simple, like family, adjust, achieve, cognitive, and so on. And then in here there are two exogenous. This is exogenous. This is what we call endogenous. This one can be named like mediator, okay, between the family and achievement. Is there, for example, oh, there is no proof that family can directly affect achievement. But don't forget, you know, if you just do direct regression, you know, perhaps it's not significant, but you can do it like indirectly, like this one. Yes, family has a relationship, or there is a significant influence of family to the achievement through the adjustment. Okay. Okay. Up to here. So far, so good. So far, so good. Before I move to the next one.
So far, so good.
Okay. So far, so good. Okay. Very good. Okay. Okay. The next one. Just like in a multiple linear regression. In a multiple linear regression, you have the R square, right? You have a R square for checking the model, whether the model is good or not, you know, okay? The same with the SEM, you know, SEM is just an advanced, you know, method of the multiple linear regression, right? So they also have several indexes in here, okay? Let me explain it to you very simply in the next one. No, not. Okay, this one first. Let me jump to here before I go back to that one, okay? Okay, so this is what we call goodness of fit measure of the structural equation modeling. This is the result of my study. And FYI, this study, I only have 12 participants, you know, only 12 participants, but my model is actually really good. Let me tell you why it is very good later. Okay, I would like to talk about the index first. Okay, there is a NFI, TLI, CFI, GFI, AGFI. Okay, these 5 indexes are like R square, the same with R square. Okay, almost the same with the concept is like almost the same with R square. Like when it's approaching to 0.9, it's actually pretty good. But sometimes in the social sciences, if you do the questionnaire based, just like my COVID-19 study, my GFI is only 0.8 something, 0.8 something. So I find another suggested cutoff like 0.8 in one study is actually, it's still fine 0.8 because the rest still 0.9, 0.9, but my COVID-19 study in here is still 0.8, 0.8. But 0.8 for the social science study is actually already okay. It's already pretty good, you know. And but this one is actually from the experimental data. That's why from the experimental data, you know, usually, you know, from if you do the experimental data based on my experiences, I always can achieve very, very high. The R square is going to be very high for experimental based data. Okay. So, and then that's what we call NFI, TLI, CFI, GFI, AGFI. Okay. And then RMSEA, this is like the same like error. Okay. And usually the minimum cutoff is 0.07. Usually, okay. When it's lower than that, you can show it like this, you know, in here. However, I would like all of you to take a look at this one. This is actually also another unique, unique, how is it that, unique index, okay? Can I ask someone why the p-value, the higher, the better? Usually people will like, oh, usually the p-value as low as possible is good. But why the p-value should be higher than 0.05? Can someone answer me? Can someone answer me? Of course, not Dr. Satria, okay? Dr. Satria knows this one, of course, the answer. Can the student or someone have, I said that, someone has an idea about why the p-value is like as higher as possible is good? Why? Why p-value in here is good? But I know some publications you cannot find the p-value here. Usually I don't show it when it is significant, you know. For me, usually like, I don't show this one, you know. As long as these indicators are good, I just show these indicators. Just like my COVID-19 study or my another study in disaster risk reduction, you know, you can check. You cannot find this one. But why in here I am so brave to show this one? Because this is a good index. Can someone answer to me? The p-value. Okay, the p-value is actually like this. Okay, I want to open my video for a while because this one I would like to explain it to you with my hand a little bit. Okay, Hopefully the video is fine. So can you see my image? Can you see my video?
I think you need to stop the share PPT first, then you share the video, Dr. Yogi.
Okay, wait for a while. Can you see my screen now with my face? Okay, so let's go back again to here. Okay, so basically, let's say my right hand is the data and my left hand is the model. Do you want your model to be significantly different with your data or not? Do you want it significantly different or not? The data and the model. Do you want to be significantly different or not? The model and the data. Okay, yeah, of course, like.
Sorry, Dr. Yogi, for the one who can answer, the assistant, the research method assistant will give you additional for your later score. Okay, you can continue, Dr. Yogi.
Because we value more significant than significant level. Oh, actually, one person sent it to me privately and his answer is very, very good. Because there is no significant difference between the assumption and the reality. Yeah, the model and the model, there is no significant difference. That's why the p-value should be higher, When the p-value is higher, it means there is no significant difference between your model and your data. It means it's very extremely good, the p-value in here, okay? But the p-value in here is actually very sensitive with the sample size, This is also sensitive with the sample size, and it's also sensitive with what type of the measurement that you collect. If you collect questionnaire data, usually here is difficult. Yeah, right, Dr. Satria. Usually the p-value in here. Yeah, right. I think you also agree with me that here is actually difficult to pass this one, but it's okay. But for experimental based, like my study, like this study, is actually, I always find this one is actually pretty good. Okay. So let me tell you this story of this publication. Okay, so this publication is like this. Okay, here. Okay, because I have a disagreement with some researchers worldwide. That because some researchers always oh, you cannot do SEM with 12 participants. I say like, hey, why not? Because here, let's see here. My independent variables, I have two. I tested the participant in the two and different environments, just like 2D and the 3D TV, and then I have the six levels index of difficulty. Okay, so 2 times 6, how many? 12, right? 12 times 12, how many? 144, right? So this is actually an example how I built the structural equation modeling. Okay, if you do by questionnaire, it's very easy, like participant 1, 2, 3, 4, 5 up to 200 or 300 and so on, But this is my my study is a little bit different with some other studies. For example, here, hey sir, why 13 in here is repeated 1 again? Why 25 repeated 1 again? Because I asked them to do in a different ID. And then up to a certain point, I asked them to do in a different environment, but the same ID, So it's repeated, the measurement is actually repeated, okay? So for example, if you want to do like, I don't know, like COVID-19 vaccine, for example, you change this, you change that, you test it to that, the same, how you say that, the same subject, whether you can do it something like this, But I don't know, for the medical related, but in the human factors related, for example, cognitive ergonomics, usually we do it like this one, okay? And the good thing is actually you can combine objective and subjective measurements at the same time. Objective measurements in here, for example, number of fixation, this is actually the eye movement, okay? I use the eye movement data. I collected several of the eye movement data. But after they completed this one, I asked them how they feel about their eyes. For example, eye tiredness, Likert scale 1 to 5, eye clearness 1 to 5, eye feel 1 to 5, and then head feel 1 to 5. So I really tried to combine the objective measures from the eye tracker or from the data, the algorithm that I got, and then in here I would like to combine it with the subjective measures. So this is a little bit different with most of the SEM, you know, that you can see perhaps, you know, it's actually like this, you know, the final SEM, you know, and again, I use only 144 data from 12 participants only, you know, but this is, like I told you before, perhaps it's not for business students, but perhaps it's for industrial engineering and then for the human factor. So in here, you know, you can see, okay, if it is square, this is indicator, right? This is also indicator, right? This is what? Oval. Oval is what? Latin, okay? This is the Latin. It's not directly measured, okay? So this actually, okay, this is actually the one that I control the experiment. You know, I check the index of difficulty, I check the environment, but in here, like the dummy code is actually 1 and 2 only. If you have 3, 1, 2, 3, nominal data, usually it's difficult. You don't know what is this one. Why is it positive? This is positive. What's this mean? You don't know if it is 3. But if you have 2 only, it's usually like usually it's clear. For example, gender to the symptoms. For example, okay, let's say gender 0.59. Let's say I dummy code male as 2. So what's that mean? Male will feel more symptoms, you know, if it is positive, right? If it is negative, then it means what? Female will have more symptoms, something like that. You know, if you do like a nominal data, okay? Someone asked me, so is it a replication but with different variables? This is actually repeated measure model, Nur Ahmad. So it's actually like a, you know, the model, you know, this model, this experiment model. Okay, let me show it to you again. Okay, before this one. Look at the table on the right. You can see, right, from here, right? One participant completed this one, this ID, this environment, and then she needs to repeat it again, this ID and this environment, okay? So this is the repeated measure model. That's why if you do Anova, you do repeated measure Anova. This is within design. One subject, he or she needs to perform several times. If you do it questionnaire, it will not be like this. It will be like questionnaire participant 1, 2, 3, and so on, you know, up to 600 or, you know, it's up to you. But in here, a very experimental based model, you know, it's gonna be like this. The Excel file is gonna be like this, okay? And based on this Excel file, like I told you before, you can do correlation, you can do regression, you know, it's up to you, you know, depends on your publication, okay, depends. But of course, the best one, save the best for SCI. This is gonna be a very good model. So in here, I can predict, you know, what can predict symptoms the most? Can be this one, you know, from second duration can be like this, from revisited fixation duration is also good. And then pupil size is actually very good for symptoms, you know, and then something like that. And then symptoms in here actually, you know, represented by 4 indicators in here. And this is actually the factor loading of those questionnaires. This is I use questionnaire base, okay, 1 to 5 Likert scale. Here is actually I got it from the real algorithm from the eye tracker itself. Okay, this one I control it. You know, this is the file that I control. Okay, so it's gonna be like you can see the causal relationship. Okay, for example, second duration is not good for symptoms. Oh, it's good, but perhaps indirect. Something like that. So in here, you can apply like, you can play around with your model, you know, and this is actually like, oh, pupil size is a good mediating variable between environment and then symptoms. You know, environment can be directly like this, yes, but it can be like indirectly like this, you know, something like that. So the total effect will be even bigger. You can see it in here, okay? There is a direct effect. There is a p-value, you got it from the software, okay? Okay, this is what? This is the beta, right? The beta value, like the beta value in the regression analysis. Okay, exactly the same like beta value. Sir, how to check the significance? Yes, just check this one, the p-value. Okay, but usually when the beta coefficient is low, usually it's approaching not to be significant. Usually, okay, and you can check indirect in here. Can you check indirect directly with that one? I prefer to check from the software because the software already show it to you, okay? And you can get the total effect. The total effect is actually the direct plus indirect. So this one plus this one is going to be this one. This one plus this one is going to be this one. So you can see the, you know, the total effect of the environment to the symptoms, or, you know, from here, this path, from here, from where else? Here, you can see, there are 4 different paths. 1, 2, 3, 4. The effect of this one to this one. So not just direct, okay? Because everything like, oh, if it's directly not significant or like directly not correlated, like something like that. Oh, don't forget, there is an indirect. There is something indirect. So you can see this one from the software, okay? So that's the basic concept for the direct, indirect, and total effect. And then this one is actually the mediating variable, okay? This one is not factor loading, okay? This is the beta coefficient, okay? Oh, but this is indicator still. You don't predict this one. This one is predicted by this one, from the latent to the indicator is factor loading, okay? This is factor loading. More than 0.7 is good. But this one is actually the beta coefficient. Oh, this is a little bit low, but still significant. The p-value when I check, let's see, 0.14. Oh, still significant. Yeah, see, still significant. Okay, up to here, okay? Before I move to the next one, to the more difficult one, okay? So far, so good? So far, so good? You sure?
Crystal clear.
Crystal clear? Wow.
Crystal clear.
Of course, Dr. Satria, for you is clear. What about for the other students? So far, so good. I want to hear the feedback from someone because I'm human factors. I like to hear a feedback from the. Yeah, very clear. Okay, so everybody can understand up to here. Okay, very good, very good. Okay, very nice. Okay, so if someone say, can you use 12 participants? Oh yes, if it is within design, like repeated measure like this can be, and the result is actually pretty good. But this is metric data. I got it from the metric data. From questionnaire, usually it's difficult based on my experiences. Dr. Satya knows that one, okay? Okay, so let's expand how you say that, the beyond normal. Because in here, I would like to do objective and subjective measurement at the same time. Like I've mentioned before, with one data, you can do so many different publications, So keep the Excel file, I mean, usually for me, I don't do it for share, for the Excel file, because one Excel file like that, you can do so many different things, so many different publications. For example, with one data, I published me with Dr. Retno Widyaningrum. She's from ITS, Industrial Engineering. Okay, we published 3 SCI journals and then 2 conferences. So of course, I saved the best. The first, I mean, save the best the first, and then the one that you can squeeze, you can do it later in the conference. I don't do it the opposite. I do it the conference. I do it SCI first, then later on I can do it with the SEM. Wait, is there any additional platform to analyze the SEM method, or just using Excel? Oh, I'll tell you later. Okay, Tasha. Okay, Tasha, I will explain it the software later. Okay, just simple later. Okay, just wait. Okay, noted. Okay, good. So in here, you can see, what statistical analysis I use. I use Anova, I use SEM, and then I use multiple linear regression, I use SEM. So here, the basic for all of this is actually from the correlation. High degree of correlation, and I do Anova, SEM, multiple linear regression, and then SEM, okay? So this is using one data, okay? So just keep your data nicely, okay? Okay. Next one, see, everything starts from here. Everything starts from here, okay? And this value will be reflected in here, okay? If it is a correlation analysis, and, oh, sorry, this should be square, not oval. Sorry, guys. This should be square, okay? This is indicator. Everything is indicator in here, okay? This is not, should not be oval. This should be square, okay? So for example, this one, okay, parallax to eye movement time, 0.156. Parallax to eye movement time, see, 0.16. See, the value is like the same, almost the same like this one. And my final prediction is accuracy. So I can do multiple linear regression. Yes, you can do multiple linear regression, putting this. But what's the difference? You cannot see the causal relationship among these. There is a story if you do SEM rather than just mathematical modeling. If just predict accuracy, oh, it's easy. For example, oh, this is not significant, that one not significant. But for example, fixation duration, it's not directly, but indirectly, I prove it, it's actually indirectly significant to the accuracy. Something like that. Okay. So keep the file, but I don't think I can do more publication with this one. I already used all of that, with this one. Okay. So this one, see, I use the correlation. This is the multiple linear regression, and this is the structural equation modeling. The story is the same. What predict the accuracy the most is going to be number of fixation, right? This is direct. Parallax is also direct, and movement time is also direct. It should be the same. See, number of fixation. See, number of fixation, fixation duration. No, sorry. Parallax. This is parallax, and then movement time. See, the same, right? So it's going to be the same. But if you do SEM, you can see this actually. This one can predict this one too, but indirect. That's the beauty story of the structural equation modeling. Okay, but this is all actually the metric data. Okay, experimental data. Okay, I don't use questionnaire in this study, but another study. Actually, I did two different studies. This study is actually no questionnaire. This study, I combine it with the subjective questionnaire, and the one with the subjective questionnaire is actually more beautiful. The story is actually pretty nice. This is the same like a square. This is indicator. Someone asked me like, oh, then why don't you just do Anova, repeated measure Anova instead of SEM? Do you know what's the difference? The difference when we use Anova, when we use SEM, it's going to be different. The story is different. Remember before, index of difficulty, I have 6. 1, 2, 3, 4, 5, 6. Okay. If you use repeated measure Anova, for example, this one to this one, you can only say what? Oh, this one is significant to this one, but you don't know how significant it is. You don't know the beta. This is the beta value, how strong it is. For example, parallax to this one, yes, significant. This one to this significant, yes, significant. But which one is more significant, parallax or index of difficulty? You can see from the structural equation modeling, oh, ID is more will affect the eye movement time more than the parallax. You can only do this one with the structural equation model. I would say that you compare it simultaneously like that. But SEM has also limitation. For example, okay, oh, I want to group index of difficulty 1, 2, 3, 4, 5, 6. I want to group them into, if it is significant, what's the group? If there is Anova significant, what's next? What statistical analysis you do? Next one. Post hoc, right? Post hoc Tukey test, right? You cannot do post hoc Tukey test using SEM. You don't know, like, oh, what group in here? I cannot see what's the group inside this one. Then you have to split it with the repeated measure Anova. You cannot do it with SEM. So it's actually purely up to you. You want to do it SEM or you do it Anova, if the case is like that. But if your case is just the questionnaire, then just do SEM will be more beautiful. Okay. Okay. This is my study with the senior high school, Let me show it to you. This is the study done by senior high school, and they run structural equation modeling, okay, senior high school, okay. In Mapua, senior high school, they have to do the publication before they graduate, okay? So this is actually their final assignment, and they presented this one in an iconized last 2 months, I think. So they evaluate chair 1, chair 2, and then chair 3, okay? And we have 52 participants. So the total is what? 52 times 3 is going to be 156 data. I collected the anthropometric data, the stutter height, eye height, shoulder height, elbow, height, and so on. So many actually, but this one is actually the one that is significant. And then I would like to measure the objective, and then the subjective is actually the questionnaire. Okay, this is I using Borg scale 1 to 7. I think 1 to 10. I think Borg scale. Okay, using Borg scale, how comfortable it is. Okay, so later on, you can see that anthropometric is actually have a positive correlation with the subjective comfort, okay? And then the backrest is actually a good, the backrest of this one is actually a good predictor. The dimension of the chair is actually the backrest, it's actually a good one in here. But the chair in here is not clear. The problem is that you have 3, right? 1, 2, 3, but which chair is this one? You cannot see in the SEM. You can only see this one in the Anova. You can do it with the Anova analysis, not with SEM. Okay, but with SEM, it's going to be like this. Okay, you can see the factor loading in here is also very unique. For example, the buttock. The buttock is actually a good predictor for subjective comfort. See, 0.92, 0.91. I think it makes sense. Your buttock is the important important predictor, important indicators for your for predicting the comfort in here. But anthropometric in here, some anthropometric is actually pretty good. Okay, but perhaps you might here, this method, bootstrap method. Bootstrap method is actually like this, okay? You try to, how you say that, enlarge the data based on the existing known data. For example, 156, you try to enlarge it to 200 or 300, you know, but it's still inside of the data is not outlier. It's actually just based on that data. You just try to add more, how you say that, you add more, how you say that, data, I would say, okay? So it's gonna be like this. See, another beautiful study. This is by Professor Yu, I think, yeah. Very famous human factors professor. See, he collected this one, you know, physical features. This is objective, right? Environmental conditions. This is objective measure. Then he combined it with the subjective, you know, job burnout, visual fatigue, job stress, you know. This is actually by the questionnaire. This is a questionnaire. This is questionnaire, and this is actually based on the data. For example, participant number 1. That time when he evaluate this one, you also collect the display size, screen luminance, screen reflection, temperature of the airport. This is actually in the airport, the study. Humidity, the ventilation, and you would like also to combine it with the subjective measure with the questionnaire like this. So it's gonna be like beautiful study. You can see the factor loading in here. You can see the beta coefficient also in here. Okay, so far so good up to here. So far very clear.
Very clear.
Yeah, very clear. Okay, very good. Okay, okay. Let's go to the medical, but I'm not someone from medical. Actually, I don't know what is this one. Actually, there is I just randomly check from the, you can, for example, someone from psychiatric or internal medicine. I think psychiatric, they do it very, you know, very well. There are so many recent studies about COVID-19 with how you say that, mini mental status exam, MMSE, and so on. You know, they combine it into one model, like with the structural equation modeling. You know, but this one you need, you really need to, how you say that, collaborate. You know, with the doctors. You know, I mean, for doing something like this. Someone asked me, comfort depend on person condition. How to deal with that so it can have non-biased output in the end? Oh, Moki, the question is simple. You know, your question is very simple. So how you wouldn't be biased? You know, simple. Collect more data. Yeah, just collect more data. Collect as many data as possible. You know, of course, you know, everything when everything is subjective. Of course, you know, everything will. For example, here. Visual fatigue, you know, how you, for example, oh, I don't think that the batak is the most important one, but don't forget, you know, you are not the only person, you know, there are 52 participants, you know, you are not the majority, something like that. Or like here, okay, for example, I think for example, I think headache is more important for me, you know, like more sensitive, but in fact, not really, you know, for here, discomfort is actually will predict the most in here. So Moki, the question for your answer is very simple. Collect more data, okay? So it can have non-bias in the end, okay? And then let's go to the next one, but I don't understand this one. This is the medical term. I don't know what is this one, but you know, this is just an example, okay? An example of the application of this one, structural equation modeling in the health related, okay? Because I think one or two of you are actually from the medical school in right now. So you can see actually in here, you can combine it simultaneously like this, okay? For example, this is not significantly directly significant, but indirectly can be significant to this one, okay? Oh, this is from the dentist, okay? From the dentistry, from the, I think this is gonna be, how is it that, prosthodontic, I think, I don't know. I think from the prosthodontic, okay, I think. Okay, see, can you see this one? Satisfaction. This is subjective, right? But there is a jaw relation, rich form, retention, stability. I think the dentist actually tried to change this one, you know, this one, and the dentist tried to, how you say that, to correlate with how do you satisfy, you know, something like that. Do you satisfy with this one? Okay, so there is a correlation, actually, very beautiful story with this one. Actually, this one perhaps stability is not directly go to the satisfaction, but indirectly, you know, through the jaw relation. You know, this is for the dentist. Okay, so if you have the very nice Excel data, you know, Excel data, like for example, you can start collecting the objective and subjective measure in the Excel data, and then up to 200 or 300, then you can just do very high, high quality, like this is a Q1 publication, okay? See, again, the anatomy, how you measure the anatomy, like engineers cannot do this, right? Engineers can only do this one, but or business people can only do this one, okay? But this one is actually by the medical, related. So that's why nowadays, I try to collaborate with the with the medical school, because they have very beautiful data, but they cannot. I would say that very limited studies that use this one simultaneously with the SEM. Okay, this question is actually answer Dr. Felix's question, about the correlation. Okay. Oh, can I just do correlation analysis, high degree of correlation? Yes. This is my publication also 2 weeks ago, I think. It's still, you can download it for free, okay? We call it confirmatory factor analysis, another term of the SEM, okay? But the difference is gonna be like this, okay? I collected 53,000 questionnaires. This is a very crazy data, 53,000 questionnaires, but collected for years of people. I mean, I got the Excel data from the Philippines government. So that's why I can easily publish this one in a Q2 journal, okay? So this is like a correlation, right? High degree of correlation, right? Between this Latin and this Latin and this Latin, okay? Because not vulnerability to natural hazards is actually consists of 3 dimensions. I would like to see the interrelationship only among the dimension itself, this one. And you can also find what good indicators for that dimension, okay? As you can see, the factor loading here is actually still okay. 0.688 is still okay. This is still significant. But don't forget, I use 53,000 data. This is a very crazy model. When I run this one, my computer is kind of like, kind of like slow down, to run this model. But eventually I got a very great model. So if you don't want to use the A to B, like B to A, I don't care A to B to B to A. It's okay. You can just use this one, covariance. You can just use like correlation, exactly like correlation. So if the model has no exogenous, has no endogenous, we just name it this one, confirmatory factor analysis. Okay, because the reviewer disagree with me when I say structural equation modeling of blah blah blah, and the reviewer attack me. I have to revise the name, the title to be confirmatory factor analysis. Okay, so that's gonna be the title. Okay, so this is gonna be the confirmatory model. Okay, up to here, very clear. Very clear. I think Dr. Felix asked me that one, the question before. Up to here, this is high degree of correlation, right? Like I told you, the correlation, regression, factor analysis is actually the basic of the structural equation modeling. You have to understand those basic, foundations in order to understand structural equation modeling. Okay, I can finish it perhaps in 5 minutes. Okay. And you can also do it like this. This is a questionnaire base, okay? But this should be Latin, this is not, should be oval instead of the square, okay? This is publication in disaster related also, they measure it by questionnaire, the questionnaire Likert scale, 1 to 5, 1 to 5, and you can check the factor loading. And later on, there is a reliability check in here, whether that questionnaire is actually good or not. You can do reliability too in the structural equation modeling. But the first thing in here, I think some of you are from social sciences joining in this lecture. So don't do something like yes, no questions, I mean, if you do like, for example, not enough safe food. Is it enough safe food? Yes or no? Then is it loss of wetland? Well, yes or no? If you do yes or no, you cannot do SEM. It's difficult to do SEM with just yes, no questions. Make sure everything, make sure everything in here is actually Likert scale is actually a good one. Don't do yes, no question, except you just want to see the effect of gender and so on. Okay. I'm sorry, Prof, if you already explained before. How do you rate the amount of significant number by hearing the subjective responses? I don't get Glenn Hugo. How do you rate the amount of significant number by hearing the subjective responses? Oh, check the p-value, okay? There is a p-value. I mean, there's a p-value and then there is a factor loading, in here. Remember the factor loading, more than 0.7 is a good representation of that latent variable. Usually the p-value of the factor loading is significant. You can check from the software, okay? You can check from the software for that questions, okay? Okay, perhaps some of you interested in the sustainability research, this is actually the questionnaire based, questionnaire, everything in here is just a questionnaire, and then this is the latent, okay? So for the previous one, okay? This is the latent, right? There is no data in here, right? So perhaps some of you don't know what is latent, So this is the latent, the latent. You can do it like, for example, the beauty of SEM is like I told you before, you don't know this is the direct, but perhaps indirectly is actually, this is stakeholder influence is actually important for social economic sustainability. Okay, so this is actually a very good, although some of the factor loadings are not good, right? For example, 44, 53, but this is again, as long as you're not fake it with your data, as long as you can explain it nicely, just be brave. This is a Q1, this is the Journal of Production Research. I got this one from the Q1. So don't be afraid. It's like, oh, this is bad. No, just go for it. Go for it. Okay. Prof, before we design the research, which one more important, a monovariable, latent, or sample? I will explain after this one. wait, after this one. Okay, you can do something like this one too in academic. I also, right now, I'm also doing together with, someone from education, faculty of education, to do this kind of analysis, okay? And finally, my publication, this one is, I collected 649. And this is actually very nice, especially when you do not have to get out, during the COVID-19 pandemic, you can just collect the questionnaire online using Google Form. So that's why SEM is actually pretty good during nowadays. I mean, you can do one publication. And you know what? This publication, let me tell you, they are just the final year of undergraduate student. And I did this study, I prepared only between 3 months. So all of them are undergraduate and they can publish in a Q2 SCI journal. So as long as the topic is hot, you have to do it quick, and then your writing have to be nice, and then the idea has to be good. And then this one, actually, I prove it that when you understand more about COVID-19, it goes more to the healthy behavior, and then eventually it goes to the effectiveness of the prevention measures. That's the only story I would like to tell from here. But the story behind of this one is actually more complicated. You can read it from in the paper. Okay, so everything in here is actually from the Likert scale of 1 to 5. Okay, so someone asked me how to do it. Very simple. From the SEM. You do it from the Excel. You copy that to the, I don't know, I use SPSS, okay? And then Amos, I use this one. Both are from IBM. So from this one, your Excel data, save your Excel data. You can do so many publications, from the Excel data. And then after that, you go to this one, SPSS, and SPSS will go to the Amos, Dr. Satya is a very, very, very expert in here, So don't worry, when you're under Dr. Satya, you're fine in the structural equation modeling, okay? So let's try to publish in this one, SCI journals if you are brave enough, SEM can be, so many publications in SCI journals using SEM, So right now, don't be afraid. If your data is good enough, don't go for a conference or non-SCI journal. Try to, rush your adrenaline and try your luck to publish in this one, So you can get the more, I would say that internationalization, okay? So final questions. Someone asked me like, oh, should I care about the, I would say that the, should I care, I would say that more important, a monovariable latent or samples, of course, based on your istiqomah, okay? The most important for me, at this moment, of course, not the sample itself, the story itself are more important than the sample itself, and this is how I build the research gap, usually, I use the title, the author, the year, the country, the journal, and then how many samples they do, so I can have a sense of adjustment, whether 400 or 500 is good enough. And there is the name of the conceptual framework, perhaps, for instance, extended TAM. And this is the most important is here, actually. I would like to list the latent that they use. So from here, I can mix and match how I can create something new from here. Okay, mix and match from here. So is it here more important and here more important? Of course, here more important, you know, I mean, rather than this one, okay? But in order to build a good model, you need a good samples, you know, good number of samples. So if I have to answer which one more important, I think factors are more important than that one, okay? Okay, next one, Joshua, okay? Joshua, how to predict the amount of data needed for modeling? What is the minimum samples? Don't do the Slovin's formula for the that one, you know. I don't do that one. I just do this one, you know, how many samples they do, and then I think based on this one, then you can have a sense of adjustment, you know. I think 500 is enough, you know. The one my COVID-19 is 649, and then the reviewer didn't ask me, you know, like the how did you come out with that number? It's not important, you know, for the SEM. I don't know, Dr. Satria got that question before. I don't think yeah, right, Dr. Satria. I think nobody asked, how did you come up with that sample? Nobody, right, so far, your publications?
Yeah.
Yeah, right? Nobody, right? I mean, we do not really care about the minimum. Usually, you know, I think usually it's not that important, okay? Which one is better method, Anova or SEM, especially for social students such as communications, law, economics? Oh, based on your question, I mean, based on, you know, what's your goal? You know, the answer of Tasha, okay? The question of, the answer for you is actually for, how you say that? What's your goal? You just want to use the causal relationship, or you want to use mathematical modeling, or you want to just test the effect of A to B. If just the effect A to B, just use ANOVA. If you use the, if you want to use mathematical modeling, just use multiple linear regression. If you want to see the causal relationship and the high degree of multiple linear regression, you can do the structural equation modeling. But if you use like questionnaire like that, it's difficult if not using SEM, you know, how can you do that? ANOVA 1 by 1, it's impossible, you know, correlation 1 by 1. How many indicators are there here, you know, perhaps 60 indicators you do, that one is too difficult, okay? Okay, Prof, is it possible to have good factor loading but not good enough model measurement? Yes, it's possible, you know, Jeremy. Jeremy, you asked a very good question. I think Dr. Satria also knows that, you know, okay? So what do we do? Okay, let me show it to you, okay, my SDM. Okay, this one. There are several indicators. Actually, the factor loading is bad. So what should I do? I remove it. The same with here, my study, you know, the confirmatory factor analysis. This one. You see, why suddenly S2, S4 disappear? Why suddenly here R1, R5, you know, this is disappear, right? Because the factor loading is bad. So I removed that, you know. So I came up with a good, only the one that is good representation for the resilience, sensitivity, and then exposure, okay? Okay, so, but not good enough model measurement. So yeah, just you can just remove it if it's not significant, okay? Maya. Usually there are studies that use Likert scale 1 to 7. So how we determine length of Likert scale 1, 7, 1 to 5? I think both are okay, you know, 1, 7, 1 to 5. I think so far there are study from psychology that answer that question, but I think based on my experience, not really important, you know, 1 to 5, 1 to 7, I think both are okay. I haven't published one study. Actually, I use 1 to 7. But it's okay. I think not really big deal. I think 1 to 5 is already okay, okay? Not that not that significance, you know, the difference, okay, for that one. Okay, so if you want to do SCI journal, you know, you have to find something new, you know, the combination, what's new. If you have no new latent variable, you'll be rejected immediately, trust me. I mean, if the story is the same, and then no new on this one, then it's going to be rejected in SCI journal usually. So make sure the construct model is beautiful, okay? The model construct is very, very important in here. The story of creating this one, you know, the story of this one, creating this one. I spent like 3 weeks torturing my students, like to remove and revise again the model. So I think they come out with the provocation motivation theory and theory of planned behavior. So the story is actually clear, okay? But do you need a theory to build the SEM? It depends, okay? For you use questionnaire based, I prefer to use theory. If you do like something like ergonomics, like study like what I did, no theory, no problem, I think. And in fact, you can perhaps establish a new theory. For example, this one, you know, I established a new theory. I call it LVI theory. Yeah, this one, LVI measurement theory. I proposed this theory. I think it's like I want to be the first person who mentioned about this LVI measurement theory. It's actually local vulnerability index measurement theory. Okay, so that's actually something new. Okay, so okay, we can collaborate. You know, I mean, Dr. Satria and I, we are very good friends, and then as long as you can have a multivariate data, you can have a good input in Excel file, we can run it to you, okay? We can run it to you, okay? So I really hope after this, we can establish a very strong research collaboration between Mapua University and also ITS, okay? So basically, that's all my presentation, everyone. Thank you, everyone.
Okay, thank you very much, Dr. Yogi.
Yeah, so it's time for Q&A.
Yeah, it's time for Q&A because actually the design for the presentation is presenting first and then second we do the Q&A, but it's okay. I think we can do the Q&A in brief, maybe about 10 minutes or 15 minutes, so we can end the guest lecture in 5:30 maybe.
Yes, I think, yeah, I think 15 minutes, I think it's okay, Dr. Satria.
Okay, so is there any questions to Dr. Yogi from the audience, from the business research methods class, or from the professor, or from the another audience that want to get the insight from Dr. Yogi presentation?
Any questions, or is it too clear?
Maybe while we waiting for the question, I would like to ask a very curious question about the publication, because in here in Indonesia we usually use the index of Scopus, which the index is so much difference in level to SEI journal. So for the new researcher, for the new professor, for the new student that want to begin the research journey or the research experience, what do you think about their aims? Do you think that they should do the SEI from the beginning, or they start to doing from the simple one like conference?
Okay. So it depends on the student, okay? Because I teach research method also, okay? So basically that SEI journal is actually the fruit from one of the group is actually, but not all. Well, you know, Dr. Satria, not all people really have courage to face the challenge or to face the harsh words of my harsh words, you know, because I'm very picky, you know, when it comes to the SEI. Not all students can I would say that can endure the pain to publish SEI. So actually, I just based on the framework, you know, based only by looking at the framework, I think you will know, oh, what's new on your framework, and when they say, oh, this is new, sir, that is new, sir, yes, I think that's already good. Okay, most of the groups are already very good, but after collecting the data, you know, the data is already very good, you know, but the problem is the writing, you know, not all of them can really have, it takes years. I mean, even two of us, you know, it takes years, right, to have a SCI level. So for me, you know, I will try. I mean, for me, you know, as long as the data is good, you know, Dr. Satya, just keep it. I mean, I will just keep it. You know, I will try to allocate my time to concentrate on that when I have time. Then I will submit to SCI journal. But when the data is already not that, you know, the model is not new, is boring, the story, and then I just publish it in a conference. Usually, I just check from the quality first. If it is okay, then I go to the SEI, and if it's possible, you know, something like that. But of course, it's up to the collaboration and also up to the students, because some students, when I want to push them, they disappear. You know, they run away, or like because yeah, it takes a lot of hard work for the SEI. So I would encourage from starting. All of you are the third year, right? Mostly.
Yes.
Third year.
5th semester.
Okay, fifth semester, very good. That's a very good time, okay, to start a research method. So they can start to build the framework and then to start how to write good writing, you know. And if it is good enough, you know, they can expand that to the SEI journal. So I think it's very popular. It's very good, you know, if you can start it as early as possible.
Okay.
Okay,
So,
someone asked Jeremy
yeah,
here.
actually,
If I do
this is-
research with the popular model like TPB, TTM, DTPB, should I worry about the model measurements? Jeremy, what do you mean with model measurements? You mean the indicators? The indicators are what in here, Jeremy?
yeah, Jeremy, maybe you can speak, or you can
Yeah, right.
explain. Or...
Dr. Satya, what is here? Model measurements in here. You also don't know, right? you either. Okay. So this one. Okay, that's this is actually the model fit. Okay, the model check. Yeah, model indices. Yeah, okay, model check. Okay, model fit. Okay, GFI and then CFI. Okay, so for it depends. You know, when based on my experiences, I don't know about the Dr. Satya, but mine for if you use the questionnaire base, usually the GFI is 0.8 is already very good. Yeah, right, Dr. Satya, right? GFI 0.8 is already acceptable, you know. I mean, people will not challenge you to you know, to challenge you even more when it's 0.8, you know. But when it's below than 0.8, then there must be something not significant. I mean, your indicators is not good, or your you know, the data is not enough, perhaps, you know. But usually, based on my experiences, when you have when the theory is already very good, like TPB, TEM, usually no problem for the GFI and then CFI, you know, usually. Perhaps you can, you know, when you have experiences, then it should be fine, you know.
Yeah, actually, Jeremy has one of the experience, right? He published with me actually for one's Opus journal. I don't know, maybe we collaborate with this paper.
I
Forgot
don't know.
about
What happened? What happened with the model?
yeah, the things that sometimes when we conduct the model fit test, not many values are acceptable for the minimum threshold. So yeah, we try to justify it because
Yeah, right.
it's impossible to reconduct the data.
Yeah, impossible. No, that's not a good, you know, when a reviewer asks you to reconduct, no, that's not a good way. You know, you can just fight that comment. Yeah.
Okay. Any more question? Any more that still want to get the
Dewie?
insight?
Dewie, come
maybe,
on, questions. Or I ask you question.
Maybe Pak
I will test your
Pradika,
knowledge.
or maybe Pak Bahalwan.
Yeah.
Yeah, Dr. Yogi, another question related to how to encourage the new researcher or the young student to
You ask more about encouragement rather than SEM, Dr. Satya.
yeah, because you know that research is not quite popular in Indonesia, especially for the
yeah.
student. And for me myself, it is quite difficult to encourage.
It's easy, you know. One of the easiest way, you know, talk about the incentive. You know, the incentive you can get. Usually, I do that. You know what I did for my students. You know, if they publish SEI, I will give a free flight ticket from Manila to you know, domestic. You know, because it's cheap. You know, it's cheap in the Philippines. It's cheap, so it's okay. From my incentive, deducted by the tickets, you know. So that's why they're so eager to publish SEI. So that's actually my trick, you know, to share the incentive with the students, but in a crazy way, because like food, like how you say that, like you know, like all you can eat buffet. It's so common, you know. So that's why like I like, hey, I just give you the free round trip flight ticket, and then they're so, you know. They're so eager. And I say like, if you publish 2, I give you the Manila to Denpasar, you know, something like that. But after the incentive, of course, otherwise I'll be very poor, you know. So
yeah,
that's
okay. I think the motivation is quite important for.
Yeah, just motivate them, or like just motivate them like, oh, your name will be in Science Direct forever. Even your your grandkids can see that, that's a good motivation. Okay, so another one is the incentive. I think is also, it's really a good one, the incentive, or a good score, get the A score. I know Dr. Satria perhaps is, no A in your class. Okay, wait. Are the CB, okay, Prahardika, okay. CB, SEM could use additive or indicator, use a reflective type of indicator. Prahar, I don't get your question. What is this one? CBSEM. Questionnaire based.
Covariant based.
Oh, covariant.
Yes.
Covariant based.
SEM or covariant based. Usually for PLSM, we use additive type, but covariant based SEM use the additive type of indicator, not only reflective.
Oh, I think that's will be okay, right, Dr. Satria, right? Yeah, both are okay.
It depends on the case.
Yeah, depends. Yeah, I think both are okay. Yeah, both are okay, Prahar. Hey, long time no see.
Yeah, actually, Pak Prahardika is one of your junior, right?
Oh yes, yeah. Okay.
I forgot about it.
Yeah. He's my junior. Yeah, he's my junior. Okay.
Sorry,
so
my camera is error from.
Oh, it's okay. It's okay. Yeah, I'm just happy to hear your voice. Okay. So no more questions. Are you sure? It looks like everybody is. I don't know. You understand or.
Yeah. Dr. Yogi, maybe this is the last question. After that, if the students still curious about the further question, maybe is it okay if they email you or they contact you privately?
Oh, sure. You can do what nowadays? What, Instagram? You can do what, Facebook? You can do what else? Email. I will try to reply. Okay. Hey, there's one question.
Yeah, one last question.
How to determine a research topic that is very interesting and needed at this time? Is there any site to know that? Okay, just like what I mentioned before, who is this one? The question is really good. It looks like who is this guy? Jeremy? Joshua. Okay.
One of my
students. Joshua, your question is very good, Joshua. Okay. Can you see the screen, Joshua?
Maybe you can
enlarge.
Enlarge it.
Okay. So Joshua here, Joshua. So this one, again, you start to build your research gap, but of course the topic should be very hot. For example, like COVID-19 should be like, it depends, the topic should be like something that people, never expect before. Perhaps it can be very interesting topic. Okay. E-commerce, I think e-commerce is I don't know, in Indonesia, what is good topic nowadays, So a good topic, and then this one, is very important. You construct the Latin. Is actually very important in here. You list one by one. So how to do this one? You have to read. You have to read papers one by one. Do you know how many papers are? So many. So many to build this one. So I just listed one by one like this. Slowly. That's why I have no life. And then list this one by one, and then try to mix and match the model. And then when I think like, after you construct the Latin, after the Latin is good, then you construct the questionnaires. For example, the COVID-19 study, this one, for example, perceived vulnerability. There are so many, studies about perceived vulnerability, perceived severity. There's so many about perceived severity, but I would like to do in the context of COVID-19, okay? Intention to follow in the context of COVID-19, right? So the idea is like the first thing you have to do, what the topic, and then after the topic, you construct, the Latin. But before constructing the Latin, you have to read, okay? Because good research should be like this one. What's the gap? What's the research gap? Okay, you cannot just pop up from your brain. It usually is difficult. You have to read. Okay, if you want to see how many papers and each always yellow mark. That's how I spend time to build that one. But I know it's gonna be tremendous work. Okay, but I hope all of you can publish SCI. Trust me, Dr. Satria is a good one. So if you wanna join with him, Okay, just join with him. Okay, as the incentive. As the incentive. Okay, share the
Yeah.
incentive. Okay. Okay.
Okay. Thank you very much, Dr. Yogi. What a wonderful presentation. I hope that all
Okay.
the audience get the great insight for this topic. And then I will pass the audio to Miss Dewi as the MC to finish up the session. Bu Dewi.
Okay, thank you, Pak Satria. So we'd like to thank you for the great sharing, for the valuable sharing from Dr. Yogi. Even not only for me, it's very exciting. Even my baby is very excited to join as well. Okay. And also to the students of a business research method as well, and also for all the participants who are willing to spend the time to get the very valuable knowledge that is shared by Dr. Yogi as well. Okay. Well, ladies and gentlemen, and the participants here, we have received most of your online attendance here. However, for those who wish to complete the online attendance, and also we have the feedback form, please kindly visit the link in the chat room, and we will send the material as well through the email that you have already registered in the attendance form. Well, we have already reached the end of the international guest lecture by Dr. Yogi Prasetyo. Again, we would like to express our great appreciations for the keynote speakers and also for the all participants here. And we do hope that everyone enjoy and get the insight.
Wow.
Very sorry for the baby. Yeah.
It's okay. Very
so
excited.
Yeah.
We cried because we're gonna end.
No, actually, it's not crying. It's very exciting.
Okay.
And also, on behalf of the organizing committee, as the MC, we would like to apologize for any inconvenience during this conference. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Dr. Yogi. Thank you very much,
You're
Miss
welcome.
Dewi, and all of the audience. Hope this topic will give you more benefit for the research. Okay, thank you. So we can end this presentation. Okay, thank you very much.